Everyone, this presentation is intended to emphasize the importance of knowing when to use the 2.5-inch handline for arriving on an incident with heavy fire conditions, and emphasize the importance of aggressive water application onto the fire as quickly as possible. The objectives are to gain an understanding of the effectiveness and manageability of the 2.5-inch handline, understand the effects of nozzle reaction forces in the manageability of the handline, and generate a dialogue about the effectiveness and manageability of our current automatic nozzles versus a smoothbore nozzle. This presentation was created by Chris Slayer from Fire by Trade from his course, The Exponential Engine, and I've modified it slightly to focus more specifically on the 2.5-inch handline. Chris requested to leave this slide to give credit to all of those who have influenced his knowledge and his career. To gain relative superiority, you must select the right weapons, know their capabilities and limitations. The longer the engagement continues, the more likely we will become reliant on increasing our numbers, as the outcome will be affected by the will of the enemy. If the first two companies expect to make an immediate difference on advanced fire conditions, we must strive to achieve relative superiority through the use of a simple plan, carefully concealed, repeatedly and realistically rehearsed, and executed with surprise, speed, and purpose. Start off with a video on how important the actions and tactics of the first two-engine company are on whether or not a fire is controllable or uncontrollable, and as a demonstration of how poor tactics and habits can impact our mission. Quick water on this fire would have made a world of a difference. All the actions that delayed getting immediate water to the nozzle, and the nozzle man's instinct to bypass hitting the fire from the exterior to advance the hose line around the house to enter in through the unburned side of the structure, were all driven by organizational practices that were followed blindly without giving thought to why they were doing them, and resulted in a failure to meet their mission. What is our mission at Rocky Mountain Fire? To protect and preserve what is most valuable to our community. All of you have probably seen these slides and statistics from UL numerous times now, but I'll emphasize it here again. It is crucial to get water on the fire as quickly as possible to increase the survivability of the rooms in the structure. Minimal exposure equals increased survivability. The longer the time of exposure to fire and smoke conditions, the survivability potential decreases. Again, coordinated fire attack and ventilation are crucial in increasing survivability. Know your weapons. We have to know what weapons we have at our disposal. Equipment, deployment options, how much hose, how it is loaded, what nozzles do we have? What type of attack would you perform on this structure on initial arrival? Which lines would you initially deploy and tactics would you use? Is this defensive or offensive, survivable or not? We'll revisit this at the end of the slideshow. In NFPA 1710, they have set a standard and outlining the minimum lines and flows necessary to attack these various types of fires: high-rise fire, strip mall fire, apartment fire, and single-family residence. Now let's take a look at the nozzles or the weapons that we have available. Deck gun with the 1.5 inch smoothbore flows 600 GPM or 10 gallons per second. 2.5 inch attack line with an 1 3/16 smoothbore flows 300 GPM or 5 gallons per second. And an 1 3/4 attack line with a 7/8 inch smoothbore is about 2.5 gallons per second or 160 gallons per minute. So what does this equate to? Da Vinci very beautifully said that simplification is the ultimate sophistication. We come with a lot of firepower, we just have to know how to use it and when to use it. Simplifying this down, deck gun is a building on fire, 2.5 inch is a residential floor or a commercial fire, and our 1 3/4 is utilized for a room or rooms on fire. We can accomplish a lot with the 1 3/4 hand line, but we need to know when to go big. The 1 3/4 pre-connect is not a total engine concept. As Andy Fredericks once said, if you put the fire out right the first time, no one has to jump out of the window. It is imperative that we choose the appropriate attack line for our fire conditions the first time. The majority of the work we encounter suits an 1 3/4 line perfectly, and it is capable of extinguishing a lot of fire. Okay, let's look at the 1 3/4 line. It's our most commonly used line, has good mobility, quick, requires limited staffing, which we're faced with quite a bit. Okay, let's take a look at the 1 3/4 hand line again and how much it flows. Our 1 3/4 crosslays and booster lines flow 150 GPM at 170 PSI, which is usually much higher than most engineers flow them at, which gives us around 2.5 gallons per second of water delivered. This is adequate for a room or a couple of rooms on fire on arrival. We have to know when to go big. 2 1 3/4 lines are not equivalent to 1 2.5 inch hand line in their ability to get to the seat of the fire and effectively knock it down. This video is a great example of how much fire can be knocked down with a 2.5-inch handline on arrival. Pay attention to how much water is being utilized from the tank on this initial exterior attack.
911.
Yeah, we have a fire at the Hidden Court Apartments.
What's on fire?
Man. This is terrible. Yeah, I know. I just went and got all them people out.
Fire dispatch calling box 0745. Report of an apartment fire. Hidden Court Apartments, 2305 Southeast 121 Avenue number 29. It's for engine 7, engine 29, engine 19, engine 30, truck 2, truck 25, rescue 7, C3, and C4. Fire map pages 5400. David on ops 3. And fire dispatch calling box 0745. Report of smoke and flames inside at the Hidden Court Apartments, 2305 Southeast 121 Avenue number 29. For engine 7, engine 29, engine 19, engine 30, truck 2, truck 25, rescue 7, C3, and C4. Fire map pages 5400. David, you'll be on ops 3 at 1611.
All right, Tim, I'll stay close for about. A resident number 31 in a wheelchair cannot get out.
Engine 7's arrived. We have a two-story garden-style apartment, several units involved. Engine 7 is going to attack from the outside with a 2.5. Engine 29, are you going to be our next driving engine?
We're right now. We're going to grab this hydrant on division.
Make it a double header.
Double header.
All engine companies on this box, make room for the trucks. We've got one narrow access for the whole building.
Dispatch, just we're going to need police for traffic control for our water supply on division and 122, just west of 122.
Division 122 west of dispatch copies.
Having 330 responding.
Houston command.
Command copy, you've got a victim, you're bringing them out.
Command agents here, we've got another victim on the Charlie side behind apartment 27, jumped from the second floor.
So in this video, the 2.5-inch handline was flown for 38 seconds. That's around only 160 gallons of water, which made a huge impact on fire conditions for crews to transition to an offensive interior search and fire attack, all off a conservative amount of tank water. It's about delivery, not duration. Again, as Andy Frederick said, I will not dispute that the 2.5-inch hose is very difficult to use, but no combination of smaller handlines can duplicate the volume, reach, and pure knockdown power of a single well-placed 2.5-inch line. As emphasized, 2 1 3/4 lines are not equivalent to a single 2.5-inch line. If we look at gallons per second instead of gallons per minute, we can get a good idea of the amount of the volume of water that is able to reach the seat of the fire to absorb the heat being released by the fire. I know that we currently have the automatic fog nozzles, but let's take a quick look at the water delivery of the 2.5-inch 1 1/8 tip smoothbore nozzle, which is currently on our alley lines and our high-rise packs. At 50 psi nozzle pressure, 266 gallons per minute of water, or 4.5 gallons per second of water are delivered. This video is another example of the effectiveness of an exterior attack with a 2.5-inch line on an arson fire started with an accelerant and wind-driven conditions in West Metro's district.
It's like the wind's starting to shift, man.
Yeah.
He's laying on the ground.
The 2.5 inch here does a great job on keeping the fire in check and buying some time for other arriving crews to transition for an interior fire attack. Okay, so let's take a quick look at the different nozzle reaction forces of the nozzles and lines that we select and their implications on our ability or aversion to operate them on the fire ground. From the previous slide, it showed that one firefighter is able to handle about 60 pounds of force, 2 firefighters, 75 pounds of force, and 3 firefighters, around 95 pounds. As you can see, our 1 3/4 lines operating at 100 psi at the nozzle are right around the 75 pounds of nozzle reaction, which I think many of us can agree is very difficult to manage without a second person on the line if pumped at the correct pressure. Driver operators usually compensate for this by reducing the pump pressure, which in turn decreases the desired volume of water flowing from the nozzle. Now let's take a look at the 2.5 inch hand line. A 2.5 inch line flown at its correct operating pressure of 100 psi at the nozzle has an unwieldy 126 pounds of nozzle reaction, making it a very personnel intensive and difficult to manage line. By switching to a smoothbore nozzle on the 2.5 inch line, we're able to drop that nozzle reaction to 99 pounds, making it a much more manageable line. And with the proper technique and very effective tool for a single person exterior attack and 2-person advancement. Let's revisit looking at the advantage of utilizing a smoothbore nozzle on our 2.5 inch lines and take some time to get hands-on with comparing the ability to manage the 2 options with the personnel that we are most likely to arrive on scene with. Alright, so let's revisit the slide from the beginning of the presentation. What are your thoughts and initial strategies and tactics on this fire? With big fire on arrival on this fire, the arriving engine decided to go with an aggressive deck gun attack and then was able to advance an 1 3/4 hand line interior to extinguish the remainder of the fire. This fire is a great example that initial impressions of what we see can be very deceiving to the survivability profiling of the fire, as the majority of the fire was contained to the front part of the structure, originating from the attached garage. As you can see, the living spaces of the house were very minimally impacted, and the room with the closed door has practically no visual impact from the fire conditions. A quick, aggressive attack helped to protect the survivability of this occupancy and achieve the mission which we are all here for. To finish up, we'll watch a short video from Brass Tacks and Hard Facts, which demonstrates the use and techniques of a 2.5 inch hand line on a commercial structure and the ability to convert the line to an extended 1 3/4 when utilizing a smoothbore nozzle.
Generally, the American Fire Service responds to bread and butter type operations and structures. However, in this case, we're going to simulate a commercial building fire. Commercial building fires are generally a lot larger and more complex than a bread and butter operation. In this case, we're going to use a 2.5 to make the initial attack on the fire. When the 2.5 inch line is laid out, the first thing we have to do before starting any fire attack is to make sure we have the right nozzle pressure. We also have to bleed the line off to get any air out of the line. At that time is when the pump operator is setting his pump pressure to make sure the proper nozzle pressure is achieved so we have the right volume of water. Keep it going. Okay, all right, good. Okay, the bleed has taken place. Now we're ready for forcible entry. Now the nozzle has to be positioned, hose line down on the ground in the rear, nozzle tip or nozzle pointed upward. So when the nozzle is ready to go, when the door is open. Ready? Okay, do it right now. There you go. Hit the pipe over to the left. Nice job, nice job. Up and down, up and down, up and down. Up and down. Okay, good job, good job. Okay. All right, we're going to move the line in so we bail the nozzle down halfway. Lay lighten up, lighten up, lighten up. Get in right into the position and throw the water. Get it back in that area right there. Up and down, side to side. That's it, kill it. Good job. Good job, guys. All right, the 2.5-inch hand line has knocked the fire down to where we can now handle the rest of it with an 1 3/4 attack line. So what we're going to do is bring the 1 3/4 line in and hook it onto the end of the 2.5-inch nozzle.
Ready for water. Water.
Okay, nozzle man.
Move in.
Okay, okay, right there, guys. Okay, good job, good job, guys. The great thing about this evolution is that it allows for a heavy hose line to knock down the main body of fire, and then we bring the 1 3/4 line in, just hook it into the end of this line right here. As long as the pump operator has got the approximate right pump pressure to put 50 psi at the tip, then we can run up to 2 lengths of 1 3/4 with a low pressure, high volume nozzle. This is a win situation for minimizing complications or questions about pump pressures on the fire ground. The benefit for the firefighters is they've used the efficiency of the big hand line to knock the fire down and bring it down to where they can now lay out an attack line that has good volume flow, but also has easier manageability and less weight to handle.
I hope this has helped to highlight the importance of how knowing your tools and weapons, the effectiveness of the 2.5-inch line, and the importance of the maneuverability of that line can help us to accomplish our mission of protecting and preserving what is most valuable to our community. Let's get out there and get some hands-on. Let me know if you have any questions or feedback. Thanks.